Good day, everyone. My name is Emezue John Chukwudi, and with my group, we are here to present our research, which the topic says Industry 4.0 in Manufacturing, a case review of Tesla Gigafactory Berlin and best practices for automakers. We'll start with the abstract. This study is carried out to examine how Industry 4.0 technologies like AI, robotics, automation, and data analytics are transforming automotive manufacturing, with Tesla Gigafactory Berlin as our case study. In carrying out this study, we use secondary data from industry reports and Tesla official communication. The study highlights that tools like digital twin, real-time data tracking, and robotics improve efficiency and reduce waste and speed up production. The finding aims to guide other car manufacturers to adopt smart technologies to enhance their own production. Introduction. The introduction explains that Industry 4.0, marked by automation, smart technologies, and data exchange, is reshaping manufacturing by offering advantages like speed, precision, and cost efficiency. Tesla Gigafactory Berlin is highlighted as our prime example for this transformation, showcasing full integration of digital tools throughout its production process. This work focuses on how this innovation supports sustainable and strategic decision making in manufacturing and could serve as a model for other car automakers. We'll move to the next slide, which is the statement of problem. Tesla Berlin Gigafactory exemplified cutting-edge Industry 4.0 manufacturing, yet detailed secondary research on its strategic components and replicability remains scarce. This study seeks to identify the element of Tesla strategy that provides the greatest value and align them with best practices in the automotive sector to guide other manufacturers. We'll move to the relevance of the study. The adoption of Industry 4.0 in automotive manufacturing is crucial for assessing societal and industrial changes such as sustainability, efficiency, cost reduction. As consumers' demands and environmental concerns grow, traditional manufacturing methods are increasingly inadequate to meet these evolving expectations. At this point, I call on my colleague to take on the next slide.
Hello, hi everyone. Thank you, Chukwudi. My name is Sadiq, and I'll continue from where you stopped. So, where the needs for research. Although the current body of knowledge gives us theoretical models or general descriptions of digital transformation in the manufacturing industries, and we have some questions. Questions 1. How does Tesla Gigafactory in Berlin implement Industry 4.0 technologies in its manufacturing operations? Question 2. What benefits and efficiencies have these technologies introduced? Question 3. What best practices can other automakers learn from Tesla's approach? Then I'll move to the critical literature review. 1. There is a vast research on Industry 4.0 during theory and auto manufacturing empirical applications are underrepresented. 2. Kegerman and Walser consider that Industry 4.0 implies automation with the help of AI. Muller 3. Muller find organizational readiness and employee training as one of the significant challenges of adoption. 4. As the case of Tesla, it is possible to notice the works like PERFA and reports by Sommer that demonstrate a company where the focus on AI and data analytics is applied over the business and production. 4. The case is not unique, and other car companies such as BMW and Volkswagen already embarked on a similar course, with Tesla being a leader in vertical integration and the software-driven strategy. And lastly, this work uses the data of both scholar and business literature to understand the position of Tesla in this change. Thank you. I'll move on to my colleague.
Thank you, Sadiq. Good day. I'll be speaking about the methodologies. Data collection process. Additional information was based on secondary data, investor reports of Tesla, videos of factory tours, scientific articles about Industry 4.0, and industry reports provided by McKinsey, Deloitte, and PwC. Key terms like Tesla, Gigafactory Berlin, Industry 4.0 in the automotive industry, or smart manufacturing were added to the names of such databanks as Google Scholars, Science Direct, or Statistas. Evaluating source authority. Preference was made to peer-reviewed journal papers, official Tesla messages, and well-known consulting agencies with experience in manufacturing research. The trustworthiness of of the informations were also provided by the cross-verification of several sources. Assessing relevance, the titles were narrowed down to ones released in 2017 or later in order to be up to date. Particular data referring to manufacturing procedures, technological infrastructure, and performance indicators regarding Tesla Berlin was given preference. Next, result. The analysis showed that Tesla Berlin extensively utilizes autonomous robots to move parts, predictive maintenance systems with AI computation, and incorporation of digital twins to simul- simulate in real time. Remarkably, the factory applies GigaPress to form the elements of car chassis, which significantly cuts down the assembly. Performance can be tracked in operations through real-time LOT dashboards. The Berlin facility will have a short production period and the emergent energy efficiency than traditional plants by the Tesla company. The degree of technological integration is demonstrated via the visual energy of robots, amateurs, schematic layouts, and workflow process of automation. Next, we have discussion of results or findings. The finding confirm the role of Industry 4.0 in support of Tesla as a strategic move to achieve an environment of data-driven, agile production. Such parties are just posed to slower adoption in the traditional OEMs, which is sometimes as a result of legacy systems. Vertical integration enables existing data flows across departments at Tesla and makes its innovation cycles fast. Such results confirm previously provided literature and reveal more information regarding the way in which software driven production contributes to better results. But the model cannot be blanket one because it would require lots of capital and sophisticated technological prowess. Thank you, and I'll be passing on to my next colleague.
Thank you, Noam. My name is Miriam Momotayo Makinde. I'm here to speak on recommendation and suggestion. One, automakers that wish to deploy the Industry 4.0 must first focus on modular automation, create central data platform, and invest in upskilling of staffs. Two, partnership with AI and robot companies can speed up adoptions. Three, moreover, factories are to be made flexible, as it is in the case of Tesla GigaPress integrations, which enables customizing the products and doing prototyping quickly. Three, it should also be strategically invested into digital infrastructure and strong cybersecurity to address scalable implementations. Then I'll be moving to conclusion. Then our conclusion is Gigafactory Berlin of Tesla is one of the biggest, is one of the brightest examples of how it is possible to integrate Industry 4.0 in automotive production. Two, data analytics, robotics, and AI result in great efficiency and and the and the possibility to see what goes on in the business. Three, such practice do not only respond to the research questions, but also offer practical implementations to conventional automakers. Then lastly, despite the existing obstacles, particularly the firms whose infrastructure is relatively aged, the research confirms the disruption-making capabilities of digital manufacturing in redefining the industry. Our next slide is our references. Thank you.